Hello everyone, and welcome to the first session of the LogicMachine training course, the English LogicMachine training course. I present you Daniel, a colleague from Embedded Systems. He will give us a small introduction of the enterprise embedded systems. Welcome.
Hello everybody.
There you go.
Oh no.
No?
I need to install some plugin.
Okay. No, I can see.
Give me a sec.
No.
Can you see my screen?
Yes.
Okay, perfect. Okay, let me start again. Hello everybody, I'm Daniel Moczewski from Embedded System, and I would like to, before we start the training, I would like to make a small presentation. I will try to be as quick as possible about the embedded system, who we are, our ideology of going to market, and then I will present you a few latest products, and that's about it. Okay, let's go. Embedded system was incorporated in 2008, and in the beginning, believe it or not, we didn't work at all about any home automation products. We were actually working on the industrial Wi-Fi routers, like last mile provider of the internet providers to your home. And our products were working in countries like Scandinavia, Russia, in really harsh environment. And believe me, those products must be extremely solid, and there's no way for any, how to say, it simply must be reliable 99.9%. And based from that experience, we've moved to the home automation, which was for us in the beginning very simple and easy market, and that's how we actually move and build into this market. But thanks to this experience, our products are actually really reliable and work extremely well in any conditions. So before I present you some products, I would like to talk a little bit about our ideology, how we approach the market, and how we work with our partners and customers. So there are three ways of selling, which is retail, via integrators, and IoT. So I will go through all of three, and I will explain you what I mean by this. In retails, it's assumed that the most of the margin goes to the manufacturer, and there is a little part for the retailer. And the customer, end user, is working directly with the devices. And there are very low prices, and this is mostly market for the big manufacturers which sell thousands of products. We directly don't do it, but we work with those products itself. Our main way of work is obviously with integrators. The discount which we provide, it's much bigger than our profit, thus we are letting our partners to earn. And we provide a possibility for the installer to do deep customization, which allows to earn even more. The more you know, the more complicated task you can solve, the less competitors you have. Additionally, some external developers can sell professional apps through our devices, which you can see on our store. IoT. One of the IoT approaches is the step-by-step. So the owner is simply going to a store, buying some Philips Hue lights, some Osram lights, Nest thermostat. But those products on its own, they are really standalone. They have a single functionality. They cannot do much. So via adding LogicMachine into the system, you can integrate everything into one common platform and add extra functionality to all those single products. And end user can even buy those products later on and get more and more functionality in his house. Some other option is that service and maintenance companies can create professional apps for our LogicMachine ecosystem. This will provide some philosophy possibility for the regular income. And something which you probably don't know, but we also work on industrial IoT. We have built special hardware with our own system on it, which allows which creates an open platform for programming with sensor and communication. We integrated all the big cloud providers, which you can see like Amazon, AWS, and all of them like that. And thanks to this, you can build really industrial application with all basic IoT cloud system, which allows to make machine learning system gateway for big data analytics. And I was just presenting this to you because that's our three direction which we work. It's our home automation, IoT, and external retail services. I'm not telling you this just because we just work on it. Have guys a think about your market, about what's happening around, and you will see that there's a lot of changes in the market right now. And we try to always go step ahead of our competition and look into the future. And if you also want to follow our future vision, simply use our product because it allows you to integrate with everything. Okay, what we have of our new products. LogicMachine 5 series, which brings many innovations like a new housing, new connectors, new CPU module, which is 3 to 4 times faster than the previous generation. A part of that, you probably will not see it, but it's actually a nice and modular system, so it allows us to build many customized devices. So, for example, if you have a project with lots of devices and some of IOs feature on a reactor or it will not fit to your purpose, talk to us because we have now very nice and modular system and we may be actually able to build for you a custom product. CanX, it's our completely new IO portfolio. If you really want to keep it simple, you can think about CanX as just new I/O module for our range of logic machines. But it's not just an I/O. CanX, it's a protocol based on CAN-FT, which is the industry standard protocol which is used in automotive, industry, even space. So every car has it, and even if you know the Curiosity toy on Mars, this little toy also is using CAN-FT. And we actually using this really industry tested protocol, which we put it on top of it, our own application, which is more or less copy of KNX. So basically, when you will be working with it, you will work like with the ETS KNX product in a way of ETS thinking, but we actually eliminated all the problems of KNX and we put it completely new product. So this extension is not just a stupid slave, which we just need to keep pulling. Once it's commissioned, it's standalone product. You can disconnect LogicMachine and it will keep working and doing its own stuff and will communicate over the bus with the other I/O components. I will not be explaining every single detail about it because we don't have time for it, but go to canx.info, read a bit about it, and you will understand what's the differences and why we actually go in this direction. We're also allowing other manufacturers to work on this, so for us it's already open protocol because we don't hide anything. Okay. Audio streaming products. All those you probably know. From the hardware point of view, we don't really have anything new, but soon we will release new firmware with Spotify. So you will be able directly to play from your Spotify account and stream music via our players. I'm already testing it in my home. Works very well. BLE, this is also something which you know, and you probably saw it, and you can integrate many other wearables for completely different application. But what we have created now, we have our BLE Wi-Fi repeater, because BLE has a limited range and a limited amount of devices which you can connect. So we created a bridge which you can put several into a system and create really nice integration to your home with all the BLE devices. This additionally works as a Wi-Fi repeater, so it will extend your Wi-Fi range in your home. Today it's in this kind of housing, but we will come soon in a new housing, ceiling mounted, so we can nicely put it into the above the ceiling. Voice assistants. It's something which is very known and common in the market now. You should know that we have already app on for Amazon Alexa, works very well. But we also work on integration of Google Voice and Apple Siri. Siri is already in a beta testing, should be available soon, and Google Voice will come soon later. We also work on now on ZigBee integration. So in some time from now, we will have an app for integrating all the ZigBee products. So for example, if we take into account Philips Hue light, we will not need even the bridge. We can talk directly to the Philips Hue light and control it. Okay, this was my quick presentation about the system. As I don't want to bother you, let's focus on the training. Here you have a few links which you can find all the information about our products, so logicmachine.net. Please, I encourage you to use our forum, where you can find all the information about solutions, add questions, and we will always answer every question, whatever you find. Plus Twitter and Facebook. Thank you very much. Gabriel, floor is yours.
Thank you. Thank you for that presentation. As he said, you can go to the OpenRB website for more information for the products that they have available. Also, the forum, it's a very great help. They answer very quickly. In this presentation, the video of this presentation will be available to you. We will send it to you by email once the presentation is over. So you won't miss any minute of the presentation. I'll have the presentation again. Thank you. Start the webcam. Okay. So we have. Okay. Let's shut the mic. Daniel will be in the chat answering for any question that I can't or I don't read at the moment. The questions, you can make them at the chat, and we will be paying close attention to the chat also. Okay, so LogicMachine. Once we will start speaking about the LogicMachine in 4 different blocks. We have 4 sessions for this course, for this training course. The first session today, we will configure the basic configuration, the importing the KNX project file from the ETS software. Tomorrow, we will see how to create visualizations in LogicMachine, how to control, create, and manage all the visualizations, all the screens that we can create. The Wednesday, we will talk about scripting. We will be making scripts to control all our devices very easily and to give a very deep integration among them, between them. And the fourth and last, we will integrate all the systems that we have available for integrate in LogicMachine. So, as LogicMachine is a web server service, we need to, once we have correctly installed it, powered it, and connected to the network, we need to open a browser and connect directly to it using the IP The default IP, the default IP that LogicMachine have when it's bought, it's the 192.168.0.10. That's the default IP. We can change it to any IP we want. We can also change it to DHCP, so our router detects it automatically. At this moment, I have already changed it. So once we've entered our IP address, it will request a username and a password. In this case, it didn't, so let's force it. It will ask for a user and a password. The default user and the default password for that user is admin. This way we can enter our LogicMachine. I have already changed it. Okay. It will give us an alert telling us that the password is not safe and we should change it. That's one of the first things we're going to do. This is the main screen. This is the app screen, if you might. In here you can see all the apps, the external apps that Daniel was talking about, that you can create, or the integrators or the other manufacturers can create different apps, and we can add them to this screen. We also have a LogicMachine, and in this first gear button, we are going to configure the visualizations, we are going to configure the objects, and all the control part of the LogicMachine system. In system configuration, we are going to enter right now to configure all the hardware part, let's say, of the system. Hardware part as IP addresses, change the admin password, KNX connection, backnet connection, and many other configurations. We have also 3 types of visualization. The web visualization, which we are going to create, it's a very impacting, very beautiful visualization that we can create using the LogicMachine equipment. Then we have a touch visualization that it's created automatically by the web visualization. We can configure both of them. We also have the control for the schedulers to add or delete or modify our schedules of the protocols or systems that we had scheduled on it. And we also have a icon for the trends, for the graphical, the historical graphics, and we will see them in this icon right here. And then we have the third visualization method, which is the mosaic. I will explain it much further in the next session. Okay, so we have also a few buttons on the top. Here, the A, it says that we are on the admin user. We can change, for example, how the order of these icons are in the main screen. We can change them in order. We can also hide some of the icons if we don't need to see them, or if the user we are configuring doesn't need to see them. In this case, each and every user has their own customization properties. We can also change the background color and the theme of the icons and all the items, also change the language. It's a very quick introduction of the personalization of the main screen. And okay, so we're going to configure the, let's say, the system itself. We have a few tabs in here. We can change in the system tab the name of our LogicMachine. That's the name that will show on the on a network finder, for example. We can change it to anything we need. We can change the password address, the password, the admin password in here. It's very useful. It's very recommended that we change the password that LogicMachine has by default, because it's not very safe to have a default password in our LogicMachine. We can also upgrade the firmware. To upgrade the firmware, we need to have the firmware file. To get that firmware file, we go to the page OpenRB, the manufacturer's page, the embedded system page, and we go to the downloads page. If we can load it. Okay. We go to downloads, and in downloads, we have the firmware. Okay, in firmware, we have to be careful because we have a lot of products that may confuse us. As Daniel said, we have a version of LogicMachine, which is the power version, which gives us 3 or 4 times more CPU power. This we can know if our LogicMachine is a power or not a power by reading the tag at the side of it. It will say it will have a small p at the end of the code. That way we can distinguish if it's a regular CPU or a 3 times CPU power. In this case, we're using a LogicMachine power. It's not a light, it's not a reactor, so we use LogicMachine 5 power. Once we have the file, it's very lightweight. We just upload it to the upgrade firmware and click OK. This process will take probably 5 minutes to upgrade and will restart automatically. Theoretically, won't change any of your configuration, but it's good if you make a backup first to save the progress of your programming, of your visualization and scripts. You can also reboot and shut down. In the networks part, we can change the IP address of the interface available, the Ethernet 0. We can see the traffic, the network usage of this interface in form of a graphic. And we can also, clicking on top of the interface, we can change the options of the IP address. As I said, you can select DHCP for auto-assign of the router, for the auto-assign of the IP of the router. In this case, we're giving it a static IP, and we have to be very careful by configuring the gateway IP and the DNS server. It's very important to configure. They won't fill up automatically. You have to write them according to your network installation. This will give access the LogicMachine to the internet, so we can receive data from weather services, from Amazon Web Services, from Microsoft Azure, send and receive data from the internet. If we don't have it configured, well, it will be very hard. Once we change the IP, we can also configure the KNX connection. In the KNX connection, we have 4 types of connection connecting to our KNX installation. In this case, I'm using TP-UART. This LogicMachine has a block for connecting directly the cable of the KNX bus. We can select to send acknowledge message to all telegrams received. We can change the address, the individual address of the LogicMachine in our KNX installation, and we can activate or deactivate the KNX IP features. If we activate the KNX IP features, we are going to be able to program all our KNX devices using our LogicMachine. Using the ETS software, we are able to connect to LogicMachine and use it as a IP interface to program all our devices in our network. We also have a support for KNX Secure. We give it a encryption key and enable it. If we enable KNX Secure, all the telegrams will be encrypted on the network and will be well protected against any attack or anything. We also have a priority, so we can prioritize the telegrams from this LogicMachine. We also have in KNX connection the configuration for the filters, the IP filters for KNX. We have the filter from IP to KNX bus, or for the local object list. In this case, we can filter the individual address. Each individual address, depending on the policy we select, we can accept all the individual addresses that are written in this field, or we can deny, we can drop or deny all the telegrams that comes from the individual addresses that we have wrote in here. In this case, no filter. We also have the same policies for the group addresses. We can accept or deny all the addresses that we write in here. We don't need, in the group address, we don't need to write them one by one. We can also select, for example, we can select all the group addresses that complies with this function. I mean, the group address 110, 111, 112 up to 11255 will be filtered in this case. We also don't need to write them right here in this field. We can also click a little check in the object list that we will see a little bit on, and it will automatically update this list as we change them. We also have the local to IP from KNX bus to the IP backbone. We can also change the same way with the IP to local, the local to IP. We have a very sophisticated filtering protocols, and well, we have a very good router, KNX router, that we can connect. We also have KNX statistics. We can see what's the TP load, the load of the telegrams on the. We also have the load of the telegrams on the bus. We can see them in graphical, and we can see them in text in here. Also, we can configure backnets, the backnet settings and the backnet objects. This we will see it further on. We also have NTP services for receiving automatically the hour and the date from the internet service. We also have the opportunity to create a HTTPS SSL certificate for encrypting our communications with the LogicMachine. We can either write our own private key, copy our own private key and certificate, or to tell the LogicMachine to generate a new one on its own. Also, we have remote services. Remote services will allow us to control our LogicMachine using HTTP commands very easily from anywhere on our network. Also, in the status tab, we can see the status of the system. We can see the model of the CPU, the memory usage, the partition usage, the internal memory usage, and we can see which serial ports we have available to use. In this case, we have 2 RS-845 and 1 RS-232. These ones are selectable by software. We will see them in a moment. Once we've changed the IP or the name of the LogicMachine, for example, once we've done any change in this screen, it's important that we click on Apply Changes. This will apply the changes and restart the LogicMachine. This takes up to 5 seconds, 5 to 10 seconds maximum. That way we will have our LogicMachine fully configured in these items. Now we are going to import our ETS project file to our LogicMachine, so we can have all our installation information in the LogicMachine, and we can control them directly. For that, we go to the LogicMachine button, with the one with the gears, and it will go to this button, the LogicMachine button. It will go to the main configuration screen for the objects and visualization and other scripts and systems. We have several tabs. These tabs will change depending on what logic machine we are on. In the case of the logic machine reactor, for example, it will show us a reactor tab, the BLE tab, depending on if we have a Bluetooth adapter connected or installed, the backnet tab. These tabs will be changing, well, depending on our system. The first tab we have is the Objects tab. In this tab, we will see all the objects that we have either received from the KNX bus or the IP, or the objects that we have imported from our KNX program, from our ETS project, sorry, or the objects that we have created on our own. LogicMachine works on the philosophy of KNX. LogicMachine works integrating and joining all the different systems into the KNX world, so to speak. Every single variable, every single data, every single object that we receive or send to any system will be represented in here as a group address. This way, for example, we can turn on and off a light. In this case, it's a KNX light, and it's represented by a group address. We use KNX objects because they have one of the best data type pool, if we may say. They have a very big database of data types. This way we can translate, we can decode the data from any system to KNX, and from KNX to any system as well. This is a way for unification of all the data. We have the group address, and we have the name of the object following the columns in this list. We also can change the IP filter policy in here, not the policy. We can add them to a certain, to a filter in specific. We can, for example, add this direction to the IP to local filter just by clicking on it, and this will automatically update the filtering list on the previous configuration page that we saw. Just like that, just checking this small objects, we can add them to the list. We also can add several items using the mass edit button that we have down here. We can edit any field of any group of objects in this case. We have also the button for the event script, which if we click on them, it will take us to the script creation page. And the moment we create one script for one of these addresses, it will show us on the address that we created the script, well, the icon in color in specific. The data type here will show us the specific data type for that object. In this case, we have to be careful also in which data type are we using, because that will say what is the value that we can send and what's the value that we'll receive. The data of the telegram will be the same, but the way we see it will be different depending on the data type decoding that we have selected for it. In this case, we have, for example, a object with a Boolean data type, and it shows us a 1 and a 0. But if we select, for example, the switch data type, it will show us on or off, depending if it's 1 or if 0. It's the same data, but what changes is the way we see it and the way we can send a data to a certain object. We also have a log button, a log check button. If we check these buttons, it will receive and save every telegram received on that object in specific, and we will be able to see it in the object logs tab. As we check it, we can see how it's automatically updating the telegrams, receiving it in even millisecond time tag. It's very precise. We can also check the export column. If we check export, we are going to be able to send it to a BACnet network, or to control it or manage it by remote services, HTTP, or send it even to a neighbor logic machine. We can receive from a neighbor logic machine the information of the different objects they have. The tags in the objects are a way of grouping different objects in LogicMachine. For example, if we have this light, we can set the tag to, for example, lights. We can put the tab lights, we can put the tag floor 1, for example, and the tag general off, for example. So all the objects that have the tag lights or the tag floor 1, in this case, we can discriminate which part of the installation, in which part of the installation is every single object. So we can group them to control them all together as if it was one object, and no send one specific telegram to every single object that we see. We also have a updated hour and date, and we can also change the value. For example, if I click on the little gear on the cylinder, we can turn on and turn off the light. I don't know if you can see it in the web camera. The small light on the left and the bottom left, it's the KNX panel that we are turning on and off. It doesn't look very well. Well, it doesn't matter. As you can see, there are 3 colors on this object tab. We have white, we have yellow, and we have green. The white objects are the objects that have a object name set and a data type set. Are objects that were added by us or were added by the importing of KNX project, but they have the data type set. It's very important, and they will recognize it as a object that we can, let's say, fully use without any trouble of misinterpreting the data, or it doesn't have any name and we can't reach them by name. We don't know what specifically does it do, each object. The yellow objects are objects received by the bus. Any telegram that the logic machine receives will be added to this list. This feature is selectable. We can enable it or disable it. We will see it in a moment. We can enable or disable the bus sniffer, as it said. For example, if I click a button, it will add a new address, and it will tell me that was just updated because I click on it. For example, if we click another, see, it will add multiple objects depending on the telegrams received. We can also mass edit these objects using the button down here, and we can mass delete all objects. In this case, I'm going to delete all objects because we are going to import the KNX program, the KNX project. For importing the KNX project, we go to the Utilities tab. In the Utilities tab, we have a lot of configuration possibilities. We can either import an ESF file. The ESF file is the file that ETS allows us to export. It's the OPC export file that we have the option in the ETS, and we have we can import also a JSON file. The difference between the JSON file and the ESF file, apart of the note that for the JSON file you don't need to have a KNX license to open the ETS and export the program to the logic machine, because we do it using a tool from the same logic machine, from OpenRB, we're going to see right now, and it adds the description of every object in the ETS KNX project to the comment section of the objects in LogicMachine. So, well, it has a small advantage, if we will. In this case, we are going to import a KNX project file from JSON. In this case, there is a tool in openrb.com/knxproj that we can use to convert from a file, a KNX project file, to a JSON file. It's very easy to use. It asks us to select a file. We click, select a file, and we select the KNX project file that we created with the ETS. It's being uploaded, and in a few seconds we will have the JSON download file. These files are they don't weigh much. They're very light. We have it here, JSON. So to install, we go to import JSON. In this case, I'm going to do something very quickly. I'm going to erase the objects and import the JSON file. We select the JSON file we have just created in here. And in this case, I'm going to add objects without data type also. When we click Save, it will tell us a list of the objects that were successfully imported and the objects that were discarded. The discarded objects might be for a few reasons. Might be because we already have them defined in our object list, or there is a problem with the settings in the KNX ETS software. In this case, we have uploaded all these. As you can see, we have 5 pages of group addresses that we can navigate among them. And we can see we have a lot of objects. So, for example, if we need to change the data type of some of these objects, for example, some percentage status values don't have a data type, we can go to search in this filter on the left, and in this case, we have it set. The name have a percentage symbol. It's very easy to click and apply filter, and it will show us all the objects that have the percentage symbol on the name. In this case, we click Mass Edit. We go to Object Properties and select the field that we want to modify. In this case, I want to modify the data type. So I select data type and search for the scale data type. The scale data type, it's the percentage data type in this case. So we click Save, and all our objects are now a scale data type. Very easily and very fast. We can also search, we can also filter and search objects by its group address. So I can search for all the objects that starts with 1, for example. It will show us all the objects starting with 1 in this case. And we can also search objects by data type. Search, for example, all the booleans. It will show us all the booleans data type, and specific data types also. We can also search by tag. In this case, we can search the floor 1. If we, no, I erased it. Okay, doesn't matter. We can also enable or disable the auto update check in here. If we check auto update, the values and the list won't change unless we manually update the page. If we check it, we will see how we are receiving information from the bus. Okay. In LogicMachine, we have 2 types of object. We have the standard object, and we have the virtual object. The difference between these 2 objects is the address. A standard object, the address, we can create a standard object using the address from the 001, which is the first address of that we can use in the KNX system. There is no voice. You can hear me. You all can hear me? Hello, hello. Okay, great. We can start from the 001 address, which is the first address that we can use in KNX, up to the 32.7.255, which is the last group address that we can use in the KNX bus, in a KNX installation. From that, we can create virtual objects. The virtual objects starts in LogicMachine from the 33/0/0. We made this just adding one more bit to the address, so we can go from 3300 to the 63.7.255. This way, we have the double of the objects that we can use in LogicMachine. In KNX, the double of the objects, we can use them in our LogicMachine. These objects can be sent to the KNX bus because physically they don't fit. The telegram will be too big, and they don't know how to analyze a telegram that big. It simply doesn't fit. When we create an object, a virtual object, let's call it virtual example, and set a switch that type. When we create a virtual object and we go to the finish of the list, it will show us a V at the side of the group address, telling us that it is a virtual address. In this case, as it is a virtual address, we can't select either of the filters. We can send it to IP or send to TP in this case, because it's impossible the telegram to fit in a standard telegram, KNX telegram. As you can see, all the objects are white because we have added them manually. Okay, so I'm going to start logging, for example, the temperature. It's all in Spanish, I'm sorry. We will create later a English version of all the object names. We click and log for the temperature sensors. We can also create and give them a suffix, for example, a centigrade degrees. Okay, and that way it will show us 28.8 Celsius degrees very easily and very fast. Also, we can set it to, this example is, for example, lux, the unit. We can set it to lux, current lux. Okay, save. So it now shows 711 lux. Very thin, very fast. Okay, when we create a new object, we can give a name to it. For example, I'm going to name it, what is this object? Just a second. Okay, this is also lux. We set the name total lux, for example. We can set a data type. We have many data types in the list that we can select. We can set the tags very easily. For example, lux, for example, light control, and set a Unix unit or suffix. We can also, from here, from the editor, log this specific object. We can also set it as high priority. This will allow us to differentiate a normal log from a high priority log and delete only one group of logs. It will be a little bit more persistent, if you will. We also can export it from here, and we have a new option, which is read during start. When the LogicMachine starts, it will send a read type telegram to this object in specific. So we have the current value of the object when the LogicMachine starts. We have this option here. Also, we can make a poll in the seconds we select. For example, we can make it to send a read telegram to this object each 15 seconds, so we can have the updated value without configuring our device in KNX. I'm going to disable this because it's already cyclic. It's already sending the information. Okay, so we have the object logs that we can filter by start date, end date, by name, by tag. We have a lot of options in here. We can, for example, filter by name. If we click looks, it will give us all the objects with the name logs in it. For example, temperature, we can go for temp, and it will show us only the temperatures received with the precision of milliseconds, which will give us, well, very, very high precision. We can also export all logs. If we click on the button export logs in the bottom left, it downloads automatically a CSV file, and we can, well, use all this information as we need. It's already in an Excel file. It's, well, practically unlimited what we can do. Okay, we also have a few pages. We can change them using these buttons right here. Okay, we also have the scripting tab. The scripting tab, we will see it further on in the third session. We can create different types of scripts for creating our logic engine of the LogicMachine. We also have schedulers. We can create, for example, a calendar, a scheduler for starting or sending a specific value at a given date, at a given hour, including taking into account holidays. For example, I can add a holiday. Just click holiday and say today is Saint EMBS, for example. Saint EMBS, it's today. What a coincidence. 7th of August. It's a recurrent, so it will be all years. In this case, we can go to schedulers and create a new schedule. Okay, sorry, the date, I believe it's not set. No, it's set, okay. We go to schedulers and we can add a new scheduler. So we click on a scheduler, we select the object that we want to control using this calendar. As we can see, for example, I can set the thermostat on or off, and I would call it thermostat 1, for example. We can say here what's the time that it will work. We can restringe, we can lock it so it doesn't work outside this range. In this case, we save it. So in order to create the hourly control that we need, we click on events, this object over here, and we add a new event. This event, we can set it to active or inactive. In this case, we're going to daily on, for example, and we can set it to sunrise or sunset. This information is given by the LogicMachine using the coordinates that we can set in the utilities tab. In this case, I'm going to use a specific time, and I want the thermostat to activate at 8 AM, for example, of all days of the week. In this case, I can check only weekdays, all the weekdays of the month, all days of the month, and all months of the year. In this case, if I set a year in here, it will only work while is 2017. In this case, if I erase it, it will work every year. And according to holidays, we can set it to do not run on holidays or run only on holidays. In this case, don't run on holidays because holidays are, for example, not workable, not laborable. Okay, and we can set the value. If we set the value, it's daily on, so I set it to on. Okay, and we have now a new event at 8 a.m. from Monday to Friday. It will turn on the thermostat. In this case, we can also create the events using the schedule tab in the main screen. We can go to the main screen and select schedules. In here, we click on schedulers and will show us this screen. In this screen, I can see that I have created the thermostat 1 scheduler, and in the holidays I can see Saint EMBS, for example. I can create another holiday from here. I can edit or delete the holidays and the events of the thermostat. In this case, I'm going to add a new event, which is daily off, for example, at a specific time, and it will be at 5 p.m. 17 hours of all days. Just in case a Saturday or a Sunday, they left it on, so it shuts off automatically. In holidays, for example, do not run or run, I will put it to no effect. Here we can select the value of the event. In this case, as is daily off, we can put a value off. This way, we can create very easily and very fast different events for different objects in calendar. It's very important that we can create new calendars for new objects using this screen. This is the screen that the users will see. The normal users can't access this configuration screen. They can change, for example, the names of the objects or create new objects. In this case, the admin has to create as many schedulers as the user is going to need, as well as the trend logs. This is just a measure in case the user doesn't know well what he's doing. Okay. We have also trend logs. We can create a new trend just by clicking on the button, new trend log on the left bottom. We select the object that we want to make the trend, the graphic, in this case, real temperature, room 1, and I call it temperature room 1, for example. We have 3 types of trends. We have the counter, which will only give us the value of the change. In this case, if the value has changed if it had changed from 20 to 22 degrees, it will tell us that it changed two values, two items. We also can set it with negative delta in the case that we want to know how much has changed the value upwards and downwards. I mean, if it has decreased the value of it, if it has increased. In this case, we're going to use absolute value because it's a temperature and we want to see the curve of the value of the variable. Sorry. We can also select the trend resolution, and we are going to set it to 5 minutes. It's the minimum resolution we can use at these trends. Decimal places, 2 decimal places for temperature, it's okay. And resolution data and daily data, let's leave it that way. I'm going to activate the show 0. This show 0 will help us to, when we want to compare different temperatures or different variables, if we don't set this always show 0, it will show us a dynamic range depending on the values that we are seeing on the trend. For example, if it's a temperature, in this case a Celsius temperature, it will show us, for example, a range between 10 degrees and 30 degrees in one variable. In another variable, it can show us from 30 degrees to 45 degrees, for example. And when we want to compare them graphically, visually on the trends, it won't let us because we have different different ranges on the y-axis. In this case, we put them to always show 0. In this case, we'll always start from 0 to the highest value that we have. We save, and automatically it starts receiving data and logging the information. We have here in schedulers and in trend logs, down here on the left, we have a button for direct link. We can select which, in this case, trend or scheduler we want to see, and what's the view mode, if we want to see it daily, weekly, monthly, or in a year. Or if we want to see multiple trends in the visualization, we can copy this address, this link, and put it in our visualization. We will use it later. And we also can select to include the IP host for using it, for example, in another browser. Once we click and copy and use that link, it will go directly to the trend visualization. The trend visualization, I can show you an example with actual data. We go to trend visualization. It's we can use it and change it very easily. We can, for example, zoom in and zoom out. Let me search for a data. Okay, excellent. We have, for example, here a week, a complete week filled with temperature data. In this case, if I hold click and move the mouse up to the time I want to stop, it will make a zoom and will show us very specifically what's the trend, what's the information that we have on that period of time. We can see here at the bottom left, at the bottom right, I'm sorry, we can see the day, the hour, and the data received at the moment. That we can do for each and every one of the trends, of the variables that we have selected. We can also export the data. We can see the data clicking the data button and download specifically this information to a CSV file, allowing us to, well, analyze it or create reports or anything we need using these files. Also, we have a previous visualization, which we can select a previous time of the, okay, show previous, excellent. We can select a previous or posterior trend that was registered and compare it to the actual, to the current. We can select two different values. It's not necessarily the 2-day information it's being received. It's the data that we select. In this case, we can compare the week from the 17th to the 23rd and the 10th to the 16th. This way we can see and compare very easily, very fast. Also, we can see multiple trends, selecting them in here. You can see here we have three different trends in one single screen, very easily and very fast. Okay, so let's continue with the tabs on the LogicMachine. We also have scenes. We are going to use them just in a moment. We have also visualization screen, visualization structure, I'm sorry, visualization editor, and visualization graphics. These three, we're going to use them when we are creating visualizations, screens, and layouts for our LogicMachine. We also have the utilities, where we imported the ESF and the JSON file, the KNX project file. We can also, in this screen, import objects from other LogicMachines. In this example, I could import objects from from the reactor we have connected on the right, using the remote password that we have to configure. This will use it just in a moment. We can also clean up and reset different options that we can select in here. We can delete and make room if we may, for different objects. We can delete objects, object logs, include high priority logs. This is what I mean on the different types of logs. Delete alerts, logs, errors, and script storage. In the factory reset, we can reset the LogicMachine two ways. We can do it clicking right here on the factory reset button. This will delete everything, and it won't change the configuration of the system that we did in the system configuration tab. And the other way to do a factory reset, it's with the button, the physical button in the hardware of the LogicMachine. If we click and if we press and hold 10 seconds, and then release and press and hold 10 seconds more, we will factory reset the LogicMachine completely. It will reset the IP address, it will reset the admin password and everything, and we will have it just as received from the factory. We can also change the date and time of our LogicMachine. We can get it from the system. They have a warning here that the NTP client is enabled. It's not recommended to change manually the date because won't work after that. And in here we can set the latitude and longitude, the GPS coordinates of our installation for information of sunset and sunrise, for automatic sunset and sunrise information. We can also create a backup of all our project. It will create a backup of the objects that we have created, of the scripts, the visualization, and I'm not sure if it will create also a backup of the configuration of the other systems as DALI, Modbus, and Ocean, BLE, etc. If we click on the backup button, it will download automatically a tar.gc object. It's a compressed file. We can also open it and see what's inside. We can see there is information, well, useful for LogicMachine. And this way we can create a backup, a fully functioning backup of the LogicMachine, that in case there is an error or we delete something accidentally, we can restore our previously made backup in the LogicMachine. This will also work very well when we are using the master-slave LogicMachine. We can connect two LogicMachines to one installation and create a very simple script to make a backup LogicMachine in the moment when the first LogicMachine for any reason stops working. The second LogicMachine will take the whole control of the installation as it had nothing happen. Just immediately, in a few seconds, even we can delay it in a second specifically. We could just have a whole control of the installation with the second LogicMachine. We also have a general configuration. This configuration it's useful in this screen. We can change the language. We have 14 different languages that we can set it. Among them, we have Chinese, Russian, Spanish, and many others. We also can set the automatic range of address. In some fields, in some windows, it lets us create new objects automatically, and this is the address that will start looking for empty addresses. If it finds any empty address starting from here, it will set it to that address. And if you don't have any order in the creation of the objects and don't have any trouble by using different objects, it will help a lot. This is the configuration for discover new objects. This is the sniffer. This is what I told you, that the LogicMachine receives a telegram and inserts it directly to the object list. We can disable it this way. We can click no bus sniffer, and it won't stop receiving telegrams, but it will stop showing them on the objects tab. The telegrams might as well go and pass depending on our routing policy, but they won't be shown in the objects list. We can also change the object log size, the default log policy. We can select to log all objects, no matter which object is. All new objects that we add from now on will be logged, or only log the selected objects. It's how we have it. We could log all the objects at once and have all the information of the telegrams received and sent registered for use. I don't know if that could be useful. We also can change the size of the alert log, the log size, and the error log size, as well as the code editor tab. This is the separation when we are writing code. When we go to a new line, it gives us a tab, so it's a little space between this line and the next line. We can also set that difference. Also, in the Utilities tab, we can change the configuration of the visualization. We will use this more deeply in the visualization session. We can change several configurations in here, and we have a little shortcut, as we may say, for configuring different options that we have already configured in the system configuration. We can change, for example, KNX connection, network settings, admin access, the code for the admin access, the remote services, and other stuff. If we click directly on the system icon, it will take us to the system configuration page. It's a little shortcut that we don't need to go back and in again in the other system. Also, we have the user access tab, where we can create new users. For example, I'm going to create Gabriel Stella, my name, and create a new login. In this case, I'm going to use Morph. I like it very much. And password 123456, 123456. And we can set the visualization access, the schedulers access, and the trends access. We can set it to full access, doesn't have any restrictions at all in the visualization, or partial access. We can select specifically which screens, which layouts, and which pages we want this user to see in when it logs in the LogicMachine. We can also set specifically which schedulers he can change, he can modify, as well as trends. We can change, in this case, we'll set it to full access. It can change or view all the trends in the LogicMachine. In this case, with visualization access set to partial, it enables this tab up here. We select visualization. In this case, we don't have anything set, so it doesn't show anything. In the case of schedulers, we can set, for example, he can only change the thermostat scheduler, not the holidays, only the thermostat scheduler. We can save, and we can log in, for example, in a new page, 192.168.1.11, with the new user, and we will see the restrictions, in this case, Morph, 1234556. Here we have. So in the schedulers, I could only go to the thermostat. It doesn't allow me to change in here at the left side of the screen, which I had the option to change between holidays and the thermostat. It only allows me to change this thermostat, as well as the visualization. We can select exactly which visualization he can see. In this case, as I am in user mode, I'm not in admin mode, I can't go to the LogicMachine system configurations or any other system that I'm not allowed. In this case, if I click LogicMachine, it will sign off and ask me for the admin user and password. This way, it's very safe. No one without the proper access can change our configuration. Okay, We also have, starting from here, we have the different systems that we can integrate with LogicMachine. A few of them, we can integrate others in the apps, in the apps screen, in the main screen. In this case, we have DALI because we have two internal interfaces, two internal gateways. We also have Modbus and Notion. In Notion, I don't know if you know it, it's a system that doesn't need batteries. A few of their devices doesn't need batteries to send telegram. Just with the force of the push in the button, it will send the telegram, so it could save us a lot of money on batteries in our system. Also, BLE, it will show us here all the data received from the Bluetooth adapter that we have installed, one wire, and starting from here, we have the alerts that were created, in this case, by the system. We can create our own alerts, and in this case, logs from scripts and error logs. In this case, we have nothing. We haven't done anything wrong by now. And we have a little tab of About, made by Embedded Systems. Okay, so let's go to the scenes. Let's create a very simple scene and very quick scene. Okay, so we click on the left button on the Add Scene in here. We click on it, and we can create a new scene very easily. Let's go to, for example, movies. When I activate the scene movies, the lights and the drapes, no, the blinds, I'm sorry, they will be in a certain state. In this case, the trigger object, the object which will receive the start, the triggering action, I will set it to scenes. I'm sorry, it's in Spanish again, and we can set the value. In this case, we know the KNX scenes are limited from 0 to 63. We can only create 64 scenes in the KNX bus, in the KNX system. With this information, we can use the rest of the 1 byte item, the 1 byte object. We have using the 0 to 64, 0 to 63 value, and then 64 to 192, which is the edit, the record scene in the KNX. We can create, starting from 192, create new scenes without the need of the configuration of KNX devices. In this case, we can set, for example, 200. It's the trigger value. When a telegram is received to this group address with the value 200, it will trigger this scene. Okay, let's save it. To set what is activated or deactivated in this scene, we go in here in sequence. We activate, click sequence, and we have certain controls down here. We click on add new object. For example, I will add the light one. In this case is loose. Light 1. We will also add light 2, and we will add the value, the percentage value of the light 3, which is a dimmable light. And let's add also the blind. Position blind at a certain height. Okay, save. Okay, we have all the objects, all the items that we want to control. In this case, we can send directly a value to it, change the value. In this case, I want this light on, and I want this light off. This one to, let's put it on 35%. And the blinds, I want full shot, all the way down, 100%. We set, and we can run the scene from here. Are you sure you want to run the scene? Yes. When I click run, it will change the status in our panel in the left. Let me move it a little bit so we can see. We can see in here how the blinds are moving, the motor of the blinds are moving, the lights has changed and has set to the status that I gave them. Okay, we can also save the values that we have sent to each of these items. If we have changed them using the LogicMachine, we can change the settings of this scene. For example, if I want to change the on value for an off value, I don't like that light turned on when I'm watching the movies, I change it and I go in here and click on Save Live Values. This will update these values and will remain like that for the next time that we want to activate that scene. We can create as many scenes as we want in as many trigger objects as we need. In this case, of course, the trigger objects should be 1 byte for have full control of the scenes. It's very easy to use. We can also create a tag. We can also create different tags for the same reason, for activate, for grouping of the different scenes. For example, if we have the automated detection of, for example, a BLE, a Bluetooth device that tells us that the device is present in the installation, we can activate or deactivate certain scenes depending on the user that it's currently in the house. We can then create a fully automated house detecting which person is in the house and controlling and changing, for example, the controls of a physical push button in the wall. If I am wearing a Bluetooth device and I am in the house, the buttons can act in a way. And if, for example, my wife is in the house and her device is in the house, the buttons can act different way according to her taste, to her needs in this case. That way we can group them and activate or deactivate them, even automatically or manually clicking on the button activate or deactivate. Okay, also we have user access, visual graphic. Okay, this is the visualization. This is the screen, the graphical interface that we will see if we have a DW1 LogicMachine. In the case that we have a reactor LogicMachine, for example, let me show you very quickly. In here, nope, I was okay. In the case that we are on a reactor LogicMachine, we will have different tabs. In this case, we click on LogicMachine. These are apps that I have already installed. We're going to install them all in the future, and we will use them all and see what they are and what they do. In this case, we have the tab reactor, which gives us the different inputs and outputs that we can configure, that we can create on the LogicMachine. In this case, the reactor has 20 different IOs, input or outputs. It has 16 configurable input or output, the analog input or digital output. We have 6 fully analog inputs that we can detect from 0 to 30 volts, I presume, and fully analog outputs that we can change from 0 to 10 volts using LogicMachine or a group address, an object. To control, for example, an input or an output, for example, I will click on the first input and we will set it to input. I will configure it so it turns on the light 1, and it is a binary we can set it here. We can set it to output, to binary output. To input, it will give us the value of the voltage in a float data type. We can set it also to on-off binary input, to a short-long binary input if we have a push button, a dimmer, relative dimmer for 4 bits, and even a pulse meter and a frequency meter. We can read how many pulses are how many times is changing the input, and we can change with which frequency it's changing. In this case, I'm going to use binary on-off. We can change the way it acts. In this case, on press, on rising edge, I want it to send a 1, and on falling edge, I want to send a 0. We can set also the midpoint. It's the point where he will detect if it is a 0 or it is a 1. In this case, if we have a input of 5 voltages, for example, a TTL output of a microcontroller, for example, we can set it to 2 volts or even 1 volt. Anything below 2 volts will be a 0. Anything above 2 volts will be a logic 1, a logic true. In this case, let's set it to 10. It's 24 volts, what we're using. Okay, and we have very fast and very easy configured a input on the LogicMachine reactor. We can send a value directly from here. We can turn on or turn off, not the switch, the light in this case. And we can, of course, click the button. Just a second. Click the button, and the value will change and will turn on or off. We can see how the object has turned green by receiving the different. Okay, I set it to a different object. Okay, save. Excellent. We can see how it changes green, letting us know that it has been updated, the value of that entry. We change it. I don't know if you can see it in here. The light turns on and off. Turn on, off. Okay. Also, let's make a simple test. Let's set this object to input voltage to see what's the voltage on that pin. In this case, let's set the delta to the minimum. We can also set it to send the value each x seconds, and we can set the quantity of seconds we want to send it. Value compensation, value base, and a multiplier to condition the signal. In this case, let's leave it in that object for testing. Okay, and we will configure also a analog output. Click analog output. Let's set it to a different object and set it to 0 to 100%. Minimum voltage 0. Maximum voltage, if I put 20, it gives me an alert and tells me the maximum voltage is 10.5. In this case, I'm only using 10 volts. So 0% is 0, 100% is 10 volts, and we have a direct real connection. Okay, let me find a small cable. So we will connect the input to the first analog output. Okay, this way it's connected. And we can see how this works. So if I change the value of the object by software in here, I set it to, for example, 75%. That should give me 7.5 volt on the input. Here we can see 7.6. It has okay. It has a very certain precision. We can change it, for example, to 20. It should give us 2 volts. Here we have 2 volts. Very easy to configure, very easy to create, let's say, amplify, to make our installation bigger in a very easy way. And this way we can create simple integration with some analog or digital devices that doesn't have the capability of connecting to any other system, such as IP, KNX, BACnet, etc. Okay. We also have a LogicMachine Ambient. The LogicMachine Ambient, it's a little wooden block that we can see on the top of the camera. I don't know if you can see it well. LogicMachine Ambient, it's a LogicMachine that allows us to create up to 5 scenes or 5 controls, object controls, by using gestures of the hand. When I pass the hand in front of it, it changes color and changes the scene that I'm selecting. And when I put the hand in front of it and let's say cover the sensor, it will activate it. We can activate, and I mean, each scene we can select if we want it to be a on-off setting, that each time that we cover the sensor, it will send a fixed value, or if it will send, for example, a toggle value, or a short, long type of pulsation. So we can control dimmer lights, we can control standard lights, or we can control an entire script using that LogicMachine, an entire scene, or an entire control of our installation very easily. Okay, I believe we have reached the time. This is the basic configuration of LogicMachine. Tomorrow we will see the configuration and how to create a very good visualization. We will create a web visualization. We will touch also the cloud services that we can connect to our LogicMachine using the cloud directly from a web page with no need of VPN or having our ports open in our router. I hope this session was of your like. We will send you the recording after the session has ended. It has been recorded. Any doubt, we are here to respond to it. I hope you like it. See you tomorrow. Have a nice day. Goodbye.